Hello guys, welcome to Zip Code, and today we are looking at another cup of code. We are talking all things at controller advice. We want to know what that is, how can that annotation assist us in our exception handling within our microservices architecture, and basically how you can plug that into your existing um, architecture. So essentially, what it's controller advice is essentially an annotation that allows us the capability to handle exceptions at a single entry point. So that annotation actually has a behavior similar to an interceptor. So if you haven't watched the HTTP interceptors on our channel, please do check that out, and you can basically see what HTTP interceptors are and what they do. So, in a nutshell, interceptors is a mechanism, rather, where we are able to intersect or sort of be able to manipulate a payload via be it an incoming request or a response that we're sending back to the user. So an interceptor is the middleman just before the data gets to its destination. So it's what an API would hit before it gets to its destination. So we intercept an HTTP request or a response to basically check if the data is valid or the request is valid. All the fields that we expect to be there are there, or maybe do some logging before we actually do perform some business logic on that particular request or that particular payload, and things like that. So add controller advice annotation is an interceptor, but it's primarily focused on exception handling when we are throwing back an exception for failed request, validation exceptions, runtime exceptions, and things like that. So we'll be looking into that. And before we jump into the code, I'll just show you what that API is going to look like. So if we go to our Postman, you will see that we have a localhost 8080 / home endpoint, and that home endpoint, when you send the request, you will see that it will come back with an HTTP exception. Let me just start up the application. Let me see. I'd stopped it over there, so let me start it up quickly so that we can be able to see the response. So we will go through the code base in just a few, and we will hash out how you can plug that um, into your architecture. The application is starting up, so that's looking good. Just to cover up some admin on this video or this tutorial, this is a re-record, and that's because the video quality was not up to standard. So I have a number of videos that I need to re-record, essentially because the configuration on my recording tool was not set up to be high definition, but now that has been resolved. So we are going to see some high quality videos with a better sound because we also have a mic. So please do feedback on the video quality and the sound quality if you can. That will really be appreciated. Okay, so now the application is started. So let's just hit that endpoint, and you see that we have an exception sent back with the correct HTTP status for not found, and you will see this in a few. So let's jump into the code, and let's see from the project setup. We're going to start on the initializer, and as always, we always start with the initializer. So the project is Maven based, the language is Java, Spring Boot version, always latest stable version. So currently it's 3.3.5, and the project metadata, the group is com.zipcode, and we have the artifact as a controller advice microservice, and the package name is the group and the artifact name. The packaging is basically jar, and the Java version is 17. So always choose long-term support versions for your Java version so that you don't have issues going forward, and you have at least that support for the longest time possible. before you can update your Java version for your project. And then the dependency side, we have DevTools, which is for live reload on our code changes, so we don't have to restart the server manually. It can just live reload when we debug or test. So Lombok, just for boilerplate code for some of the annotation like access modifiers and things like that. Spring Web, we basically go to scaffolding and endpoint, just as you saw on our Postman. We have some endpoints that we will be going through, so we need Spring Web available. So these are the three that we need. They should suffice for this particular project. If you are interested in the code base, we do have it in our Git repository. So go to controller advanced microservice and you will basically find the code base right there. So with that being said, let's jump into our IDE and see how the code looks like. We're gonna go into our Spring Tool suite, and the first things first, we always go to the main Java, so the application main class. That's basically just the main class to start up the application, and the next package will be the controllers, so that you can see how that guy looks like. So let's go to a home controller. We have two controllers here. We have a home controller and a subscribe controller, which essentially with this tutorial they do the same thing, but this is just to show you that you can have multiple controllers. All your controllers in your application will be handled by one controller advice, which means all your exceptions will be intercepted by one controller advice globally across your microservice, and that's what we're going to see in a few. So the home controller has the REST controller annotation, and the request mapping is home. As you can see here, we do have a home endpoint, which is a get. Be very careful there. So it has the get mapping over there, and that throws a home exception. And we also have another mapping, which is a post mapping, and that post mapping throws a custom exception. So this one, you will see the message is home failed, and then the post mapping has a custom exception, which is home post failed, and we will see how the control advice handles these two exceptions. We'll see just now. So let's jump into the before we jump, let's just go to the Postman so that I can show you the message. So if you look at the payload, the response payload of the exception, it has the time, it has the status, and it has the errors. And you can see that this is home failed. So if I go to home post, which is actually this request mapping, if I go to home post and I send the same to the same endpoint as a post, you will see that we have a different error message there, which is home post failed. So you can see that different mappings can throw different exceptions, or different conditions can throw different exceptions, and then those will be handled by the controller advice accordingly. So we will see that in just a few. And as I've commented here, if you pull the code from our repository, you can basically add your custom logic here. Then based on some validation or some checks, you can then throw the appropriate exception. So let's go to subscribe controller, and subscribe controller is pretty much the same as home controller. The only difference is that this guy has a request mapping of subscribe, which is what we have on our Postman right here. So on subscribe, you will see that if I send this request, it will come back and it has a 400 of bad request, and that message is subscribe failed. And then if we do the post, it will basically throw us a different message altogether. So you see the response there, it has the time and the status, which is a different status, and the message is also different. Subscribe post failed, that's the message for that. And you can see that the subscribe get has a subscribe exception that has been thrown, and the post is throwing a custom exception in that sense. So now let's jump into the exceptions themselves, the custom exceptions, before we go into the control advisor. So let me just show you the custom exception that we have. Is basically just a class that extends a runtime exception, and we have a default constructor, and we have a parameterized constructor which just has a message, and we just pass that into our superclass, which is the actual message that gets returned or written here on our error list. So that's about that. And then home exception follows the same logic. It extends the runtime exception and with the two constructors in the same way. And then subscribe constructor also does the same thing. So with add control advice, you can throw built-in Java exceptions, or you can, like we did here, create our own custom exceptions so that we can be able to handle them better because we know why that exception was thrown. And because it's a custom exception, we have more control of how we basically handle that exception and basically feedback the appropriate message for our exceptions. So custom exceptions work better, but you can use the readily available exceptions as well. So now that that is set up, let's look at the domain. The domain doesn't have a lot. It has one POJO, which is just a payload for our response. You will see it has a timestamp, it has a status, and it has the list of string errors, just like as we have on our response, the timestamp, the status, and the errors, and that's the error messages that we will have over there. So if we have multiple messages to feedback, we can do that. So at this particular point, we just have one, which is enough for what we're trying to achieve. And then we have our annotations here, which are provided by Lombok to allow us to set, get, build out a new instance, all args and no args constructor, so we can basically use these. And that's basically it for domain. And then finally, the man of the hour, let's say the controller advice class, which is what intercepts all our response when we throw an exception on our controllers. So if you look at this class, it has the annotation at controller advice. So this controller advice allows us to have a global listener to intercept any thrown exception from our REST controller. So if a REST controller throws an exception, then that exception will be intercepted before it's sent back to the user or the consumer. So it will be intercepted and then handled accordingly before it is thrown back as an HTTP response. So we have one function here, or one method here, that has add exception handler, and in the exception handler we tell it which exceptions to listen to, and this is where the you want to handle the custom exceptions, or to list or define the exceptions that you want handled by the control advice. Here we have the home exception, subscribe exception, and the custom exception, and all of these exceptions will come in, be intercepted here, then they'll be passed in as parameters, and also we have the web request that actually is coming into or that made the actual request, and we need to send it back to that same request as a response. So what we do when you get in here, we have an HTTP header that we set, or we instantiate, and once we instantiate this guy, the next thing that we do is check if the instance is, if the exception is an instance of home exception. If that is true, then we want to say the HTTP status is not found. So let's say this is user not found exception, something like that. Then if it's a user not found exception, then you'll have an HTTP status of not found, and then, or like a not found exception, it will basically be a HTTP not found status, and then we'll basically cast the generic exception that we got from here as a parameter to a home exception. And once we have that home exception, we basically go and handle that exception on its particular handle method. So the handle method is right over here. So we can see that handle home exception takes in the home exception, the HTTP headers, the HTTP status, and the web request that we just received. And then we have a list of errors here, and based on the exception that we got, we just say exception.getMessage, and we assign that to the list of errors. And then what we do is pass that into the handle exception internal, and handle exception internal, we pass in the exception, and we build a new API error, which is from our domain, we set the time to the current time, and we set the status.name, which is what we see over here. The status.name is method not allowed, just as you can see from our API response, is a method not allowed. And then we pass in the errors that we got. So if here we have multiple errors, we can just list the messages and basically populate the API error, and that will essentially be thrown back to the user. And then we pass in the HTTP headers and the status and the request accordingly. So if you go to handle exception internal, you will see that it has an exception that it takes in an API error, which is the actual body of the response, then the HTTP headers, the HTTP status, and the web request. So any of these, whatever we set on any of these is what is going to be feedback to the user. And you will see here we check if the exception is an internal server error, then we will basically handle that to set on the request. We set an attribute of error exception attribute, and then we basically pass in the exception with the scope of the request. And basically we return a new response entity with the body, which is what we have over here, and the headers and the status just like that. So once we pass these guys, it basically then sends back a response just like that. So all our exceptions will pass in through the handle exception internal, and you can see that home exception handler, subscribe exception handler, as well as custom exception handler, they all follow the same logic. They call handle exception internal with the respective parameters. So this is all the same in our use case, but in your use case, you can customize it. Let's say maybe subscribe exception. If you want to add more meat into the message, you can basically customize it. If you, let's say maybe the exception here would be, let's say, let's just do something like that. Home handler says that, and then we can basically take a similar message and we can basically add it over there, and let's say subscribe handler says, and then we say custom will be custom, let's say maybe exception handler says, then we save this, and you will see that now our exceptions will be much more clearer as to where or which handler is basically throwing back the message. So if you come back here, for example, and we hit this guy, you will see that custom exception handler says, because this is a custom exception that was thrown. But if we go to, let's say maybe get home, and we basically send that request, it will now say home handler says home failed, right? But obviously your exception will be much more descriptive, and you can see that I made the change here on the global control advice handler, and in our controller we still just throw the exception with that actual message, and it's able to then append that according to the message that it got. So this is what advantage that we can have to handle all our controller or HTTP exceptions in a much more, in a single point of entry, and basically easily maintainable, easily adaptable, and also we can then allow our developers to know which exceptions are handled by our APIs and which generic sort of a design do we follow for us to actually feedback failures on our API calls. So if you can see, we did the home exception. So even here we can add some more meat according to our requirements. And then the other one is basically if the exception is an instance of subscribe, we then throw a bad request. So if I go to subscribe, this side, and I send, you will see the status is bad request, and we also have the more descriptive error message right there, and that's because we set the status to bad request, and we basically pass that to the handle subscribe exception, and basically that exception is taken care of. And then in the same way with custom exception, for the custom exception, we just say method not allowed. And obviously, this is just for demo purposes. You can put the appropriate HTTP status as well as the message according to your requirements. If none of these exceptions were thrown, then we just want to throw an internal server error according to that, and we can add more meat into it according to what we want, so that if there's an exception that was thrown that is not catered for here, we can just throw it as an internal server error, but it will be much more cleaner than throwing back a state trace to our users. We'll throw back something that is much more meaningful and easily to consume on our user side. So that's basically about it with the controller advice, and it basically offers us the capabilities to handle all our exceptions in a single point and be able to adapt them according to what we want in an easily maintainable way, and be able to feedback exceptions in a generic sort of a payload, just as we see over here. So I think for this one, that's about it. I wanted to keep it short and sweet and simple, so that you guys can plug it in on your side, be able to handle exceptions on your APIs, and also just handle exceptions much more better for your consumers of your microservices or your users of your microservices. So for now, I would just request for you to like and subscribe. Please do comment on the audio quality and the video quality. And I think for this tutorial, that's about it. Until next time, for now, cheers.